Okay, we're going to prove some logarithmic properties. The first property I'm going to prove to you is that log base n of a to the x equals x times log base n of a. First thing I'm going to do is give you a couple examples that you can see that it works. For instance, log base 10 of 10 cubed. Here's my claim, that this equals that. Well, let's see, which means on both the left-hand side and the right-hand side we can evaluate and come up with the exact same answer if this is true. So let's start with the left-hand side. What exponent do I put on a 10 to get 10 cubed? And the answer is 3. That's quite clear. I need a 3 placed on 10 to get that. Right-hand side. First thing I need, order of operations, find the exponent I put on 10 to get 10, and that exponent will be a 1. Question is 3 equal to 3 times 1? The answer is yes. Now this is an example that the theorem works. However, it's not a proof. I need to design a mechanism to show that it's going to work for everything always. So we begin our proof. I'm going to start with the left-hand side. And what I'm going to say is that the log base n of a to the x is a value. It will simplify and give me a value. And if it does, I'm going to call that value the value y. Now, I've made no assumptions about this value. I haven't said anything at all except for I don't know what it is, and I'm giving it a generic name. Now, what I'm going to do next is deal with the property of logarithms. First, the definition. I'm going to read this. This says that the exponent I put on n to get this is y. So I'm going to take it out of logarithmic form. The exponent I put on n to get a to the x is y. Next step. I'm going to use my property of exponents. And I'm going to say that I'm going to move the x from the right-hand side to the left-hand side by taking the x root of both sides. You learned that in the property of exponents last semester, which says I can take the left-hand side and the right-hand side and both raise them to this exponent. By doing so, on the right-hand side, I'm going to simply have a, and on the left-hand side, I'm going to have n to the y over x. Now, next step, I'm going to put this in logarithmic form. What I'd like you to notice is that y over x is the exponent I place on n to get the value a. Next step, I'm going to move the x to the right-hand side by using the property of multiplication, multiplying both sides by x. And on the left-hand side, I'm left with y equals x times the log base n of a. Notice what happened. I started by letting that amount be y. by using my property of exponents and the definition of logarithm, I was able to change y into this value. If all of my properties of math are valid, which they are, then I have proven that this value is equal to this value.